If you're like me, when you start a new project, you tend to get obsessed with it. Welcome to my first devlog for my semi-open world action RPG named
Anguish.
I started developing this game a few months ago in the Godot game engine, and I've been absolutely loving it so far. This is the first game that I've really tried to create, and I hope to share this journey through these devlogs. The core elements of this game, I've been taking inspiration from my favorites, such as RuneScape, Diablo, and Resident Evil. It might seem kind of silly, but some of the things I remember the most from these games is just planning my progression. Whether that's sitting in the save screen or my inventory in Resident Evil, listening to the somber music, or when I'm sitting at a bank in RuneScape trying to figure out the next thing that I'm going to do. And speaking of RuneScape, I really believe that it has one of the most interesting quest systems of any game that I've ever played. Specifically, there's this one quest that has stuck with me for years, and it's called Underground Pass. You have to travel through a dangerous cave where you have to find unique ways to pass over obstacles, solve puzzles, and fend for yourself on limited supplies. It feels like a journey, and that's something I'd love to capture in Anguish. As I had said, the game will be semi-open world. And by that I mean, although the player will be able to explore the game, it will progress somewhat linearly. My goal is to retain value in the earlier parts of the game by creating content in those areas that is unlocked later in the game and also just stays relevant. This is a pretty large topic, and I'm going to be saving this for another devlog. A passive skill tree is a dynamic branching of upgrades where one can choose their own path through. I had thought about making these just directly tied to individual weapons within the game, but I also want to make it so that the loot you get is somewhat randomly generated, like Diablo. But when I actually went to implement this, I realized that there was no way for this information to persist. They were simply being instantiated by an ID rather than containing anything tangible. So lo and behold, the point of this video is to implement The first step to being a good programmer is to steal somebody else's code. So this is what I did with Godot's saving demo. How their demo works is basically you define each class you'd like to persist to be in a group, and for the sake of this, I just called that persist. This allows for easy retrieval using the get nodes in group function. This will retrieve a list of nodes that are within that group. Then we can check to see if a node has a save function, and if so, call it, and add that save data to an ever-growing list. And then once that's all done, we can simply save that to a JSON file. The issue that I had with this was this created a lot of duplicate code. For example, across multiple objects, you will likely be saving some scene data, such as the parent or the file name that was used to load that object. So what we can do is we can make some static class that contains generic save functions. We can now define a list of save functions. Then iterate over each of these and call them to create the entire save data for that object. This generic solution doesn't cover all edge cases, and you'll likely need to still make some unique save functions for certain cases. Now for the harder problem is to actually load everything back in. For this project, there are 4 main steps that I see happening in the loading process. First, you have to clear parts of the current tree that are persisting and are about to be loaded in. And then we need to create each object, assign all of its persisting properties, and then add that instantiated object as a child to its original parent. Now we can take a look at what this looks like in code. The first thing we're going to want to do is to make sure that the save file actually exists. And then we can load in that JSON object from that file, clear the persisting nodes, and then for each node data in those loaded nodes, we can load that object in. For the load object function, it simply checks to see if there's a file name, and if so, it will instantiate that object. For every object that persists, I had to define a restore function that takes in the node data and the parent, applies all of the node data properties to itself, and then adds itself as a child to the parent passed in. We finally have a finished product, and you can make some changes, hit the save button, and then reload the game to see that it all persists. Now that I have a way to save data, I can go back to the original goal of creating the passive skill trees. But I believe this warrants its own video, so thanks for watching, and I'll see you next time.